So, according to me then, next one up is Lawrence, is it?
Move to 11.
Oh no, not. So it's Andy, and I said I'd give him a ring beforehand as well. Oh dear. Let's see if we can get him a... So you can see Sob's coming back in a minute. It's very strange actually, it's sort of like through the looking glass. Temporal shift. Right. It's about a minute, yeah. It's an amazing amount of compression that goes on afterwards. Sorry, PC's deciding to be slow. Yeah, just starting Skype up. Just stopped. Theoretically. Andy?
Steve,
Ah, yeah, great.
how you doing?
I'm all right. Let's go live.
Can you see the video?
Are you sending your video? No, I can't see it yet. Yay, I can see you now. Great.
Yeah.
Hi, Andy. So I think you're going to start the presentation, or just lead us into the presentation, and I'll try and run it from this end, and then pick up any questions at the end, if that's okay.
All right.
So let me just get the presentation up.
Yes.
So, there we go. Right, let me... Right, do you want to say anything before I start it, Andy, or just head into it?
Alright. Just say
Okie dokie. Let's try that big. Right, I'll put it on the screen. Hopefully, I'll turn the camera around and you should be able to see it.
Hi guys.
How do I get rid of that? I might need to put you down there.
Hi, I'm Andy, VK3YT. I'm from Project Pico Space. I'll be talking about our HF tracking setup that we've been using on our Pico flights. So HF payload on a balloon was one of the high priority tasks that we were looking at when we started with high altitude ballooning. It seemed to be an interesting idea at the time. Once we look at it closer, we also realize that it was quite messy. With HF, you need filters, you need power amp, you need big antenna. And there's no one cheap solution like what you can get on VHF and UHF. So we started a test with HF payload using a Raspberry Pi on an up-down balloon. This is a few years ago. The Raspberry Pi put out around 250 milliwatts, and it was programmed to transmit WSPR, Thor 4, JT65, and JT9 at alternate time slots. We use long wires for full-size dipole antenna matched for 30-meter band. So the whole flight lasted 5 hours, which gave us some good initial test results for the future HF flights. So this is the Raspberry Pi setup we had. It's very cheap and nasty HF generator. The output is square wave, so you need a lot of filtering. And it generated lots of hits. The inside temperature of the payload went up to 55 degrees at 20k altitude, so that's pretty hot. So we learned a few lessons from the initial test flights. So HF is quite doable on a balloon. It's very messy. It's very power hungry. We had a bank of lithium battery for the payloads. The range is pretty good. We had WSPR Sport picked up in the US. We have JT9 picked up across Australia. And in summary, for up-down flights, the VHF, UHF payload are still the best. There's no real reason to go with HF payload for the up-down flights. It just makes things so complicated. Simple things like antenna on HF, it takes a bit of effort to build and to deploy it successfully. So when it came to Pico balloons, things become slightly different. In Australia, because of the geography we have, the UHF tracker get out of range very quickly. In the best case, we can have some sort of loop that will send the balloon in some inland path for a few days. But in the worst case, they could get out of range in a few hours. So rather than sending a floater across the ocean and wait for a week or two to hear from it, it's much more attractive to continuously track it by HF. So HF tracker, which is a logical choice here. So the first thing we looked at was how to generate the IF for HF payloads, transmitters. The Raspberry Pi is definitely not for Pico. The DDS synthesizer, good candidates. At the time, there are a lot of cheap eBay modules that's got a lot of things built in. Make it very good to test out. There's also the SI Lab clock generators that could be used. So this is what our main HF tracker looks like. This version used DDS synthesizer. I generate 25 milliwatts of output. And it's pretty small. So the second part of the payload beside the transmitter is the HF antenna. For the initial test with the Pi, we knew that dipole antenna worked well. Then the problem became trying to make it light enough to fit on a Pico balloon. The magnetic thin wires are good to use as dipole antenna arms. We found that to reduce the weight, we generally run unmatched dipole, so with a length of around 6.5 meters instead of full length, and that seemed to work okay. Generally, the antenna will add in around 2 grams worth of weight to the tracker. So once you got the transmitter and the antenna sorted out, we got to work out what protocol you're going to run on the tracker. We'll try to find something that will work with FLDG. So all the backend upload is done automatically for you. Things like RITI, Thor, or Olivia. So what we found was RITI is just no good for HF. A slight noise or fading will just kill it. Thor is much better, but still it is not workable with the balloon telemetry tracking. Olivia was highly recommended from a lot of ham amateur operators, but after a few tests we had to discount that as well because it's just not good enough to be used reliably in a HF tracking environment. So the bad news on that is you can't use FLDG if you don't use those protocols. The next set of protocols we looked at was the JT set of protocols. So we had JT65, JT9, and WSPR. So JT65 was on the first Pico test flight we have. Works really well. We cut through the noise. We got almost 100% decoding when the balloon was doing a loop around Australia. This is what the JT65 spectrum looks like. It's about 180 hertz bandwidth, got 65 tones. Duration of transmission is around 48 seconds, and it can decode down to minus 22 dB signal to noise ratio. It provides 13 text character for telemetry encoding. It's worked really well. The one downside we saw with JT65 from the first flight was the wide bandwidth of the transmission. You can't fit many of those on a passband of a radio. And if there's any interference in the passband, it's very likely that they actually be within the bandwidth of the JT65 signal. JT65 can handle the interference really well, but it still needs that bandwidth. So on the second test flight, we decided to try out JT9. So it's got much smaller bandwidth than JT65. It's supposed to have 2 dB better of sensitivity than JT65. It got the same 13 text characters available. So it seemed to be a good candidate. There was a concern that JT9 wouldn't work well in a real-life HF environment because of the small spacing between the tones, and we had to test it out. So the test was a success because JT9 worked as well or even better than JT65 with the reduced bandwidth, and fading wasn't a problem. So the other protocol that we tried out was WSPR. I think it stands for Weak Signal Propagation Reporter. So it's designed to act as a beacon, so you can tell when the propagation picks up. It's got really narrow bandwidth of 6 Hertz. It can go all the way down to minus 28 dB, and it transmits around 2 minutes. It sends grid locator and power level, and nothing else. And that is the main limitation of WSPR, because you can't send the normal telemetry that you want to send on a balloon. So at the end, we decided to use WSPR for our course location. So that'll give you the grid square. You can use a power level to encode the altitude. And we use JT9 for telemetry from the balloon to send back things like lat, long, altitude, satellite, battery, speed, temperature. These are encoded in 2 JT9 packets, and the server will decode those packets for space near. This is a real-life waterfall of the JT9 signal on the left and WSPR signal on the right. You can see the WSPR signal take up 2 minutes slot, and the JT9 signal actually showing 2 JT9 packets. Each of them take up around a minute worth of transmission time. The bandwidth of the JT9 signal is quite larger than the bandwidth of a WSPR signal. So after all the initial testing, and we determine a suitable protocol, we have to work out a way to automate and streamline the tracking process, especially for the floaters where they could last for days or weeks. You can't expect the receiver, the listener, to do any manual task. Even tuning is probably not a good idea. So we decided to modify existing WSJTX software by Joe Taylor to allow uploading of data. You can download the modified software from picospace.net. There's binary and source code. The binary right now is only for Windows. We're testing some setup on a Raspberry Pi to do decoding of WSPR and JT9 and control the rotator and the radio at the same time. But that software is not on the website yet. This is what the modified software looks like. You see two additional options here. So location will allow the software to upload the location of receiver, so that will be shown on space near map as the antenna towers. Telemetry will allow the JT9 packet to be uploaded to the server. All other functions of the software stay exactly the same. So you can use it as a normal JT65 or JT9 QSO software. So the other thing that we experimented with was the transmission duration for the packets. We found that 30 minutes separation between the packets works well, and we go down to 10 minutes when the battery is fully charged. This is slightly different from the UHF, RITI, and APIS, but you sort of get used to it. So with 25 milliwatts from the balloon, the propagation is a big helper. We found that it's varying throughout months of the year. The impact of propagation is quite significant on a small power payload like what we have. The other thing that we also found was there's black holes around South America and South Africa where the balloon will just disappear for a day or two before reappearing again. If the signal path is down through the pole, that will pretty much stop the signal completely to the extra polar absorption around that area. So the most important part of the end-to-end setup is the receiving stations. So the software and the protocol works really well in unattended mode. So once you've set it up and you've got your radio fitting the software, all the decoding and uploading done automatically. So you don't need to tune the software. Make it very easy to set up a receiving station. So we have a lot of volunteer receiving stations around Australia and New Zealand, Cook Islands, South America, South Africa, North America, Europe. Ideally, what we found is the local noise level is really important for receiving a weak signal from the balloon. The interference from suburban environment just killed the reception. We also found that the certain type of antennas work really well for tracking balloon. It's not all about gains, it's about directivities and noise level. So in summary, from the test and experiment we did with HF tracker and Pico balloons, we found JT9 and WSPR work well together for Pico trackers until someone come up with a different protocol. That will be pretty much what we stick with. The maximum range we've seen is around 19,000 kilometers for WSPR and 15,000 kilometers for JT9, which is pretty impressive for 25 milliwatts transmitter. We also found that the time between packets of 30 minutes is okay for HF, because you can leave the whole setup unattended. The other thing we found was the 30-meter band is a good all year round band for this type of telemetry reception. 20 meters has its moment. In summer generally is good. When it's good propagation is good. But 30 meters band, the 10 Mach band, is pretty good all around. The other thing that we found also is that even with the extended range of HF and with the help of propagation, you still need listener in every continent. It's misleading to look at the map and underestimate, the effort that you need to actually cover the range that you need. So the more listeners you have in the continent, the better. Well, I hope that gives you an idea of how we set up our HF tracking for the Pico space balloons. Thanks for your time.
Okay. Let's call him back. Oh yeah, just found that the sound doesn't go over the radio. It doesn't come out the back. Unless it's through this. Yeah. You'll probably hear it though, because. Andy, I'll put you back on screen. Did you hear the round of applause you got at the end off of YouTube? It's still coming, is it? That sounds about right. You did get one. It was a good one too. I'm just putting you up on screen if I can. We'll do a Q&A now.
Okay. Well, first thing I'd like to say is it sounded really strange listening to your voice. Voice standing
Okay. You got your video on, Andy?
Uh,
Do we need it? Well, yeah, be nice, wouldn't it?
yep.
Hey! Has anybody got any questions? I'm going to have to pass you this when you talk. Questions, ladies and gentlemen?
What is the power arrangement, batteries and solar?
Sorry, can you just...
I wonder what the power arrangements are in terms of batteries and solar power or whatever.
Okay. The battery is LiPo, so it's around 3.6 to 4.2 volts. On transmitting, it consumes around 62 milliamps.
Right, and is there any solar on there?
Sorry?
Is there any solar power for recharging the LiPo?
Yes, that's correct, yes. So most of the extended range loader on HF, we have to solar power. So generally the daytime is good because of the temperature. Battery pretty happy. 60 milliamps in daytime to okay. It generally struggles at night time when it gets cold.
Indeed.
Some of the battery dies pretty quickly, and we basically end up with just daytime tracking.
Right, I understand that, yeah. Did you ever try to overcome the problems with charging at low temperatures, or do you just restrict it to when the battery was warmer, the recharging of the battery?
Sorry, Steve, can you repeat
Yeah,
that?
can you hear me better, actually? I'm thinking it might be coming through the microphone on this. Sorry, what's that?
I wondered how he was handling the recharging of the LiPo when it was at zero.
So did you try and charge the LiPo when it was below zero, or did you just wait till it was above zero to charge it? I think.
No, what we found generally with the good thermal insulation, by the time the sun's got any power to charge, the temperature is zero or about zero already.
Makes sense, yeah.
So yes, we generally charging done about zero.
Above zero, so you just limited it to doing that. Okay, cool. Anybody else with a question? I think I'm going to have to relay it. So, sorry, Lawrence. We'll start with you. It's probably just try speaking now.
Okay. Yeah, I just wondered if it was a regular lithium polymer battery or if it was some kind of special battery or modified battery in any way.
So Steve, can you repeat that?
So was it a special polymer battery, a lithium polymer battery, or was it modified, or was it just standard?
So part of the experiment was trying different types of batteries, and we found some of them work better than others. So generally eBay type, generally the remote control type of LiPo.
Okay.
The other thing we found also is thermal insulation does help in the way that you wrap, so that the generated heat actually will warm the battery up. But for that to work well, the battery had to stay at least partially alive at night.
Okay. Let me pass. You might be able to hear it a bit better now. I've turned the volume up on the PA. Here we go.
You described a dipole antenna that you used. Did you experiment with any other kinds of antenna? Any other arrangements?
Did I hear it correctly? Is that a question about did I use other type battery beside LiPo?
No, it was about dipoles. Did you try anything other than a dipole antenna? Was it just dipole?
For the antenna, just dipole intentionally, but we think that we might have a vertical by accident in the last one of the past few flights when we think there was damage to the antenna and make it like a vertical, and it was only received in very limited range in South America. So dipole seems to work the best.
So what was the arrangement? Was it a balloon, a long line from the balloon down to the payload and then another line below it. Is that how you did it?
Yes.
Yeah,
Yes.
yeah, done that myself.
And you just need some sort of string to support the white at the upper part.
Sure, okay. Other questions, ladies and gentlemen? No, I think that's it then, Andy. Well, thanks for your help
Cool.
this morning. It's gone reasonably well as can be expected, I think. Thanks.
Thanks, guys.
Okay.
Glad to be here and have a great day.
Okay. Brilliant.